now we're going to get into APIs and promises. So currently, our catbook is static. There isn't any information showing or using the fact that we're different users. So, I mean, unless you hard-coded it, I don't think it says your name. It says like Shannon Wu or something. And also, like every time you click, you get like some number. But then whenever you refresh, it just resets back to 0. And if you look to our posts, they're all the same for us. And maybe we'd want some kind of data that is specific to each user. And so that's where the backend comes in. Backend is used for data storage and data manipulation. So our front end would send requests to our backend, and our backend would send whatever refined information that our front end wants. And so we're going to be using the client-server architecture. So currently, you guys are the clients, the browsers, and you guys will be sending requests to some server. And after the server receives your request, it's going to send back a response back to you, the client. And basically, the server is just where we have all of our information. And so right now, whenever we're doing npm run dev, the front end is being served to you. So all the HTML, CSS, and JavaScript it takes to render your website is all sent from currently a server, but it's not necessarily sending any data back to you guys yet. So we'll be working on that. For that, how do we actually send requests to a server? There has to be some standardized way. We can't just send an email to a server asking for data. We can't like telepathically ask a server to send us information. So there has to be some standardized way of sending information, or rather sending requests from a client to a server and then receiving a response that we can access. And so the protocol that we'll be using is HTTP. And basically what HTTP stands for is Hypertext Transfer Protocol. And you've actually been using HTTP requests and responses every time you request a website, or I don't know, you want to like load a specific video from YouTube. The way that you get all that information is through HTTP requests. And HTTPS is just HTTP, but secure. So all the information that's being sent back and forth is encrypted in some way. And so people who are in between you and the server won't be able to actually decipher what your request has. So it's safe from anybody trying to, I don't know, modify your request in some way or receive information in a malicious way. So right now, we're going to be going over the structure of an HTTP request. So we have the request target plus parameters, HTTP method, headers, and body. And to give you guys like some kind of motivation to like why we care about this structure, I'll give you guys an example. So if we were to, let's see if I can. If we were to send a request to YouTube to show us any videos that have weblab in its description or in the video, then we would be sending this URL into our browser. And I'll talk about the many ways to send HTTP requests later. But just putting a URL into a browser is one of them. So here we have a YouTube request. And it's going to be a GET request since we want to get data. We aren't posting data to a YouTube server. So that'd be like, I don't know, uploading a video to YouTube, which would be a post request. We have some metadata. And then our body of the HTTP request would be empty because it's a GET request. And so now we're going to go into the nitty-gritty of an HTTP request. So first, the target URL and query parameters. So HTTPS just tells us that, well, the protocol that we're using to send a request is HTTPS. Next, we have www.youtube.com/results. And that's the URL of a server. So this is where we're sending our request to. Generally, YouTube would have like some kind of mega computer with like a bunch of data storage, and we'd be sending it to the computer with that IP address. And then /results just tells us that the computer for YouTube is going to have like some kind of endpoint where we would send requests specifically for like searching specific YouTube videos. So here in this case, we have the videos with the search query being weblab. So if we just sent a request without any query parameters, we wouldn't receive any YouTube videos. But this search query helps us refine what data we want to receive from our server, our YouTube server. Wait, any questions before we move on? No? All good? Okay, cool. So HTTP methods. So there are many types of requests to send to a server. Of them, there are GET requests, which gets data. We have the POST request, which sends data. We have the PUT request, which places data, and the delete request, which deletes data. For this class, and mostly in general, you'll be using GET and POST requests for sending and posting data. I mean, receiving and posting data. Yeah. Questions? All right, so now we're going to look into the request body and request headers. So the request headers for an HTTP request is all the fancy stuff that comes with the information that we want or the information that we're sending to a server. So for example, if we're sending some data to a server and we want to specify, what's the time step of this request? Like what language is this request in? All that metadata about our request is stored in our request headers. Then our request body is where we put any data associated with a post request. So for example, like if we want to post a YouTube video into YouTube server, we'd be sending a YouTube video through the request body. However, for GET requests, again, like before, we put whatever parameters we want in our target URL. So an example of a request body would look like this. So a request body uses a JSON format. And basically what a JSON format is just like key value pairs. So, you can see that for a name or key name, a key of name, we'd have a value that's actually a name, and a language, specific language. So this is how most of our data is going to be organized, and that is how the request body is organized. So now that we've covered how a request is structured, we're going to look at how a response is structured. So let's get into that. So status codes. So whenever we send a request to a server, the server is going to respond in some way. And an example would be the dreaded 404. So this means that the resource that you were looking for could not be found. And this can happen if, I don't know, you put in the wrong URL, or maybe the resource you were looking for was moved to a different endpoint. So you'd have to look through the website's documentation to see where you could find the information that you're looking for. Another common error is 400, a bad request. And this could happen if, I don't know, you malform your query parameters. So you put a query parameter that maybe doesn't exist for the data that you're looking for. Or, yeah. And then another common one is 500. And 500 means that, I don't know, the server errored out in some way. So, yeah. So it's not your fault, it's the server's fault. And then you have a 200. 200, it's good. Your request reached the server and it was handled correctly. And so generally, like the hundreds place of your error code signifies like what kind of code error code it is. If it starts with a 1, it's informational. It starts with a 2, you succeeded. Starts with a 3, you got redirected. Starts with a 4, you did something wrong. And then start with a 5, server did something wrong. And usually you'll be seeing 2, 4, and 5, and maybe some 3s if your website uses caching. Right. Cool. So that's the response body. Any questions? Cool. All right. I mean, sorry, that's status codes. So now let's look at response headers and the response body. So the response headers, like request headers, is just a bunch of metadata about a request. And usually you don't have to worry about that stuff, just content type, content length, boring stuff that we don't care about. Then we have the response body. So the response body is going to hold all the information that we requested from our server if we sent a GET request to server. And usually, whenever we have a post request, like if we're posting a comment onto Catbook or something, we'll probably send it back just to confirm that this comment was actually posted on our website. And again, this is also in JSON format. So that's the response. All right. Cool. Questions? And so I mentioned earlier that there are many many ways to send requests. And we'll actually just like go into a Catbook example to see like how these requests are sent from a website. So you guys don't have to do anything, but let's see. Exit. Let's go to Catbook. Catbook.example, or actually weblab.is/example. All right, let's see if I can screen share this. Okay. I'm sorry for the Zoom people, you can't see this. Okay, cool. So if we open up the inspect tab and then go to network, network is where we see all the requests that our website makes. If we request, we see all these requests to PNGs, requests to the comments, requests to stories. And if we actually click on one of these, let's click the one that represents our stories, you can see that it's a GET request because we want to get our stories. The URL is going to be the server that we're using. This is not the Catbook that we're implementing right now, so it's a different server. And we can go to response. You can see that this is all in JSON format. Yeah. So that's just a cool way if you guys want to mess around in the network tab to see more about requests. Okay. Let's see. I need a screen share. Now, another way to send requests, like usually you're sending requests through your browser. You can just type a URL. Well, those types of requests are all GET requests, since like, you don't have any space to put all the information you would like in a post request. Like we put stuff in the request body, but there's like no place to put stuff in the request body for a URL. So there are other ways to actually send post requests. And I think like an interesting example of another way to send requests is through your terminal. Like you can do it independent of your browser. So if you guys would like, you guys can open up your terminal and just run curl https www.google.com, and you'll end up getting a bunch of HTML, CSS, and JavaScript that represent the website for www.google.com. And so you can see we have some HTML up here, and then like this is badly formatted. It's all JavaScript. And so that's just another way to send HTTP requests. And then finally, the way that you guys will be sending HTTP requests will be through JavaScript. So I'll give you guys like a second to parse all of this. But essentially what we're doing is we're using the fetch function in JavaScript to send a request to some server. And we abstracted out the fetch function so that you can just put an endpoint and the parameters for get request and for both the get and post requests. And this is how you'll be requesting / modifying most of your data. And you'll be using it in Workshop 3. So I'm going to pass it on to Daniel so that he can go over APIs. Oh, wait. What's happening? You can just use my computer if you want. Okay, because you're also, okay, yeah. Yeah.
Hi, everybody. Hi, I'm Daniel, and I'll be talking about APIs. So API stands for Application Program Interface. And in summary, it's basically a set of endpoints that some service provides that allows you to make requests to that service in order to perform a function. That might sound confusing to you, but I'll give a few examples right here, and then I think it'll make a lot more sense after I explain the examples. So a lot of companies provide APIs that you can use to essentially incorporate into your own website. So just as an example, the Google Calendar API, our weblab website at weblab.mit.edu actually uses the Google Calendar API to display all of our lectures on our course calendar. So we just have a Google Calendar that we update, and then the website automatically pulls from that Google Calendar and updates our website. So the way that we do that is by using a Google Calendar API that Google provides that our website is then able to use to display our calendar. Another example is the Amazon Selling Partner API. Let's say you wanted to incorporate into your website a way for you to essentially buy a product on Amazon. Then you could do that by using the Amazon API to incorporate some sort of Amazon interactive portion of your website, so that if you're selling some product, you're able to click some buttons on your website, and it kind of shoots off some Amazon order for your website. And then lastly is maybe an OpenAI LLM API. So OpenAI provides a bunch of APIs that you can use online, where essentially you can send it some request, and then it'll respond with some data. So maybe you send it some random request for help me with my math homework, and then it responds with some response with that answers your question, basically. And there's thousands of APIs online. Some are free, some cost money. I think the OpenAI one might cost some amount of money per query that you have, but in general, they are there to help you be able to do things that maybe are really difficult to do or impossible for you to do on your own. Yeah. So the purpose of an API, you're going to need to access data or something, or do some things that maybe your website doesn't have access to. And the servers won't just let you, for example, Google, they won't just let you look directly into their servers and be oh, what's going on over here? Oh, and then you'd be able to just kind of look at every single user potentially in their database, and that would potentially be a security nightmare, because you could maybe just look at everybody's passwords and be oh, great, I can just log into my friend's account now and do whatever I want. But what they do provide is a way for you to interact with that data by doing predefined functions that they give you. So yeah, so that's what APIs essentially are. And now you can basically do whatever you want, or not whatever you want, but kind of a lot of things just by asking the right people and in the right way. Yeah, so as Lucas talked about already, we are working in kind of a client-server model. So far, we've only coded our client in Workshop 2, but we're going to be coding our server in Workshop 3, which will respond to our client using HTTP responses and requests and responses. So you might imagine that your client sends a GET or a POST request to your server, and then your server responds with an HTTP response. That server is eventually going to be connected to a database, which will store data that your server needs, and so that that data will persist forever. Even if your server crashes, it'll be able to retrieve that data still, because the data will still reside in that database. Now let's imagine that you wanted to connect like some APIs to your website. Let's say like Google Calendar and OpenAI, and you want to interact with both of these. Essentially like the things, I don't know, responses and requests will look like is that your client will send these responses through your server, and then your server will forward those responses to the APIs, which will then be able to like respond back to your server, and your server can then respond back to your client with like the response that it needs, basically, being like, hey, you asked for this from the API. I got that from the API, and now here, I'll give it back to you. Yeah. And so your code is basically responsible for everything in the client, the server, and the database. In Workshop 3, we'll basically be talking about how to get this client and server interaction going. And yeah. So what is the purpose of the server? You might ask, why can't this client just directly interact with the database and directly interact with the APIs? Well, in our model, the client is kind of like the browser. So if your client was able to directly interact with the database or the other APIs, then that would mean that like when you inspect element in your browser, you would be able to see everything that is going on, which is kind of a problem, because then like maybe you would be able to see like, oh, here's my API key for this API, and like if you're writing a website, you don't want users of your website to be able to see all of like the potential like keys and like database passwords and stuff like that that you're using. So you kind of want this server that you manage, and then clients are able to like request and respond to your server, basically. So the server is kind of your code that you control, whereas the client is kind of like the client's going to be users of your website that you might not be able to control exactly what they're doing over there. Yeah, so the easiest way that you can think of is just like going in and inspect element and like changing some stuff around on your website. Like that's not changing what's going on in the server, but it's changing on what's going on in the client. Yeah, so as Lucas already mentioned, whenever we access a URL, you're making a request to an endpoint. So just some examples. These are from our example website. We have a GET request for all the stories, a POST request for a story, et cetera, et cetera. I think I'm just going to skip past this part. Yeah, so we're going to just look at one quick example. How much time do I have left? Oh, shit, OK. How much time can I? No, OK. OK, no. OK, so here's the YouTube API. OK, I won't go over the example, but I think in the slides you can just kind of look over it, and look, I think it's decently, hopefully, kind of self-explanatory. When you have an endpoint and query parameters, those query parameters will get formatted after the question mark, each following like key value pairs. So yeah, the colors are just mapped to the same color. Hopefully that makes sense. Yeah, here's some examples of some really cool APIs that you could think about incorporating into your own website. I already went over a few of these, but you know, like the dog API, you can just like query for like cute examples of random dogs. Yeah, I would encourage you guys to look over these and maybe some other online API lists to like get an example for maybe things that you can incorporate into your own website. Okay, yeah, so we've gone over how like these API requests work if you just like write it out into your URL, but you can also do these in JavaScript. The way that we do this is using the get and post functions that Lucas talked about. Basically, whenever we, the first parameter of the get or the post function is generally just the endpoint that we want to query, and then it's followed by whatever parameters that we want to use, and then the get and post functions will actually just do all the work for you. It'll send a fetch request for that URL. So basically, you can think of it as these functions are doing the dirty work of actually filling in the URL and filling in the body of it for you. So you can just fill in the URL and fill in the parameters, and that's all you need to worry about. Okay. Yeah, sure.
Okay. Can you go to the announcements slide?
Where's
Oh,
that?
shoot, really? Is it not there? All right. Could you guys open up the feedback link and give us feedback? We'll give you like 1 minute to do that.
No worries. Yeah, while you're doing that, I can show you guys something cool from the example. If you look at the answer here, it should work if you copy paste into your own browser. So if you like just do it here, you'll get the response that, let me zoom in a bit. You'll get the response from the YouTube server that tells you, that is essentially listing out all the playlists that we requested, and we use the weblab YouTube for the request. So if we just take this ID here, for example, and then we go to youtube.com/playlist, and then list equals, and then we've copy pasted this in here, we'll get the IAP 2025 playlist from weblab. So yeah, that's pretty cool. I think, yeah, this should work on your own computers too.